All right, so we're going to start today with a joke again. And big joke here, ready? How many mathematicians does it take to tie up a package? Give up? You want a second? Okay. None. All you need is a cord. Ha! Oh, I can hear you laughing from over here. It's pretty funny. All right, so let's take a look at this example here from yesterday. We need to find the measure of angle FGJ. Oh, okay. So we find this right here, and we know that the angle measurement, we'll call it x, is going to be equal to 1/2, and since this is inside the circle, we're going to find the sum of 52 plus 31. Add those together, and we get 83. Whose stupid idea was it to do this? Because now, well, why couldn't it be an even number? Because now we get 41.5 is equal to x. It's okay if we can have fractions, no big deal. Now let's take a look at this problem right here. I'll use a different color. So we want this angle here. It's always important to draw out the angle so you don't get confuzzled. And now it's right on the edge of the circle. So we know that this measurement is going to be half this arc. So what's half of 130? That's right, 65. So this angle measurement is 65. All right, the Ferris wheel. I gotta lie. I can't lie. I mean, Ferris wheels are not my favorite thing in the world. It's just kind of slow and boring. Go on a roller coaster if you want to go high. I want to go fast. All right, that's right. I am Ricky Bobby. An observer watches people riding a Ferris wheel that has 12 equally spaced cars. Find x. All right, so we have a tangent and we have a secant. And we know that they're equally spaced, right? Okay, and this is outside the circle, so I'm going to be looking at the difference between this angle measurement here. So we need to find this angle measurement here, and then we also need to know this. All right, so this has 1, 2, 3. So it's 1, 2, 3. So this is a third of 12, right? Oh, sorry, it's 3, 1, 2, 3. So that's a fourth of the whole circle. And a fourth of the whole circle is 90 degrees, right? 3. Well, okay. Okay, so yeah, it is. Okay, so we know that this is 90 degrees here. Well, okay, what about this segment here? Well, we have 1, 2, 3, 4, 5. 5 of the 12, right? So 5 divided by 12. So it's 40 for just 42% of the circle times 360. And so we know this is 150 degrees. Okay, so that means this angle, it has to be 1/2 the difference of 150 and 90. All right, the difference of that, well, it's 60, right? So what's half of 60? 30 degrees. All right. Oh, I love these puzzles. They're the best thing ever about geometry. So much better than proofs. We need to find the measure of arc CE. Oh, that's small. All right. Great. How am I going to do this? Well, to find this arc, what would I need? Well, it'd be helpful if I know this whole arc here and that angle. Well, let's just start throwing in things that I know, right? So I know this is 83 because they're vertical angles. All right. I know that this plus this has to be 180. So that means this is 97, which means this is also 97. Okay. So I know this is 85 from here to here. Well, does that mean I can find this segment here? Well, yeah, because that's inside the circle. So I know that 97 has to equal 1/2. And this is 85 here. Plus this measurement here. Let's call that x just for now. All right, so multiply everything by 2. So I get 97 times 2. All right, and then subtract 85. So I know that this measurement here is 109. All right. Great. So what else? What else can I figure out? All right, this one's a tricky one, right? But I know that this is 25 degrees, right? And I know that this arc here, this big arc here, I'll use pink. This big arc here is made up of 109 plus my missing distance. Let's call this y. Because why am I looking for it? I don't know, it just tells me to. And we know that's 25. So that means, and this angle is 48. So that means 48 has to equal 1/2, and it's out of the side of the circle. So 109 plus my y value minus this 25. All right, so multiply everything by 2, make life easy. So we get 96 is equal to 109 plus y minus 25. Okay, 109 minus 25. You see, I already did it. So we have 96 is equal to 84 plus y. Well, y has to equal 12 degrees. And there we go. I got mail. All right, so those are the answers and how to get them. I'm guessing this is the only one that gave you any troubles. But I want to take a look at some theorems, and then you are on your own to answer the example problems. All right, so here we go. Theorem 11-6-1. One would think that you could find a more exciting name for a theorem, but oh well, that's the numbering system that we have. Oh, we do. It's called the chord product theorem. So I don't like these so much. So this is called the chord product theorem. And here's what it says. It says if I have a circle and I have 2 chords inside the circle. And let's say A, B, C, D, and let's call this O, just for something different. All right. So here's what this says. This says that if I multiply this segment by this segment, that I will get the same number if I multiply. Let's not use blue, I already used blue. How about this off red? All right, so that means that AC, sorry, AO times OC will equal BO times DO. This reminds me a lot of the geometric mean idea. So this times this has to equal this times this. Okay, I think we're willing to believe that. Well, we have something that is very similar to it called the secant-secant product theorem. And so we'll get the same basic idea. All right, so A, B, C, D, and O. So same basic idea, that the product of A, D times DO has to equal BC times CO. So this times this has to equal this times that. Well, we have a chord, secant product. Guess what's missing? Nope, it's not a tangent. Nice try. It is a secant-tangent theorem. And this is the one that really reminds me of the geometric mean idea. So here, we have our circle, and we have our tangent and our secant. So what this says is, let's go A, B, C, O. That AO squared has to equal BC times CO. All right, so these are the three situations: inside the circle, outside the circle, and a tangent. I guess we should say two chords, two secants, and a secant and a tangent, and that you are to use to answer the following questions. All right, good luck.